there are two parts to it. This is the actual impact structure here, as it shows up on the gravity map, which this is. But the impact structure it hit the Precambrian continent Columbia, and then eventually the Precambrian continent Laurentia broke off of Columbia and took this and a lot of other stuff with it, and it ended up as southeast Missouri and most of North America. About 1,500,000,000 years ago, on the Precambrian continent Columbia, there was a big, huge piece of rock that fell out of the sky, which is it made this circular impact structure right here. And when you go through the analytics, you can determine that the radius of the impact structure was about 5 miles, and the volume would be 4/3 pi r cubed, which comes out to 500 cubic miles. 500 cubic miles is a big piece of rock. First off, we're looking at the gravity map of Missouri. This is the whole state of Missouri, and this is the gravity map of Missouri. Okay, the impact structure is down here, and it extends a little bit into northern Arkansas, and it includes, I think, around 20 different counties altogether. And this is where in the interpretation that I'm using, this is where the asteroid hit, and made a gigantic impact crater and a fracture zone that went all the way through the crust down to the asthenosphere, which is the next layer down, and started a mantle plume, and the mantle plume melted the lower crust and also caused the St. Francis volcanic field, which is under us right now. And the individual pieces of the asteroid that broke off at the time when the asteroid impacted, the thing fell out of space and went kaboom, and pieces of it fell all over the place. And the pieces were big. The pieces could be 10 to 20 cubic miles each, and they probably flew out 100 miles or so from the impact site. And it's quite possible that some of these impact fragments are underneath places like the Pea Ridge mine in northern Waterston County and the surrounding similar Olympic Dam type ore deposits, and they may actually be the source of mineralization because you had the impact happened in the ancient Precambrian rocks, and above the old Precambrian rocks you have Precambrian volcanic rocks, and above the volcanic rocks you have the marine sediments, the sandstones and the dolomites and so forth, which are much younger than where the impact happened. So if you happen to have one of these big pieces of asteroid down on the ground, and you had an igneous intrusion coming up through it, the igneous intrusion would have assimilated iron and cobalt, nickel, rare earths, a lot of different materials, and also generated hydrothermal activity, which would have taken a portion of the metals up higher into the volcanics and created things like the Pea Ridge mine and other mines in the area. So you can work that backwards. We know where the Pea Ridge mine and the other mines are. If you look deep enough under it, you might find the asteroid fragment, or not. I mean, this is a new conceptual model. I think it's a very valid model, and people say, well, if you have these giant ore deposits, if they are ore deposits, why haven't we found a bunch of them here recently? And the reason is the conceptual model is new, and because it's new, nobody's been looking for the thing. I'm Bill Jud. I'm a geologist, and I typically look for ores of metals and things like that, and oil and gas, and about 40 years ago, maybe a little longer now, I was hired to supervise the reopening of the cobalt mine in Fredericktown.